Okay, here we go. So today we look at applications of exponential functions and logarithms. Really kind of the exponential side of things. We're going to look at compound interest and continuously compounded interest. I'll give you a couple examples here and nature. So let's look at the first example, and we'll talk about that formula in a second. It says a radioactive substance decays in such a way that the amount of mass remaining after t days is given by this function, m of t is equal to 23 e to the negative 0.0043 t, where m of t is measured in kilograms. So we got this radioactive substance. It's 23 kilograms. It's like, what, 50 pounds? Okay, it's fairly significant, but it's slowly decaying. It's getting smaller, okay? And we're trying to see what's happening over time. Now, do you think it decays like once every week, or do you think it's constantly decaying? So do you think I'm using the equations on the left or on the right? And notice how the letter E pops up. So E represents a number for how things continuously compound in nature. And so you see that E pops up in this situation. So let's talk about how to find the initial mass. The initial mass means the mass at the very beginning. What do you think I plug in for the time if I'm talking about the very beginning? 0. So m of 0 is equal to 23e to the negative 0.0043 times 0. Now, you could go to your calculator, or this one's not too bad to work out. What is negative 0.0043 times 0? 0. What is e to the 0? 1. Anything to 0 is 1 times 23 is, so 23 kilograms. How much mass remains after 21 days? What do you think we do there? Plug in 21. So m of 21 is equal to 23e to the negative 0.0043 times 21. Now, some of you might be able to compute that in your head. I can't. I'm not quite that gifted. So I'm going to use my handy-dandy calculator. And as I take e to a power, I go second natural log. That gives me the e raised to that power, negative 0.0043, and times 21. And I get 21.01. So at 21 days, it's about 21 kilograms. That's just by chance. You okay with that? So far, so good, right? Easy. Let's change the problem a little bit. After how many days does it have a mass half of the initial mass? So am I solving for the mass in this situation, or am I solving for the time? The time. So what should I plug in for the mass if it's half of the initial mass? Yeah, 23 divided by 2 is 11.5. So 11.5 equals 23. Times e to the negative 0.0043 t. So we just said that in this problem, you're given the mass, you want to find the time. So let's talk about how to solve that equation. What do you do? I want to get at t, so I'm going to have to move that thing, and that thing. Which moves first? Divide by 23. Thank you. And I get 1/2 is equal to e to the negative 0.0043 t. Shoot, I don't know how to get rid of e. Oh, that's right. Wendy, did you just say that to make me mad? True that. Okay. So that's gone. And on the right-hand side, I get negative 0.0043 t. And then on the left-hand side, I get the natural log of 1/2. Natural log of 0.5, we get negative 0.693. Negative 0.693. Want to solve, so I'm going to divide that by negative 0.0043. And I get 161.20. 161.2 days. I mean, that's kind of helpful to know, right? I mean, you're not solving these types of problems in chemistry or physics unless you know how to deal with logarithms and exponential functions. All right, who wants $1,500? Okay, all right, Maddie's got $1,500. Good for you, Maddie. What does it feel like? Wow, sounds great. So what do you want to do with it? What do you want to buy? $1,500. What would you go buy? New phone? Some cool shoes? Cheap car? Okay, all right. Got big plans. $1,000 for the phone, $500 for the car. All right, so you're going to buy it. Or maybe you're going to invest it. You're going to put it in a savings? Let's say Maddie says, you know what? I'm not going to buy something for $1,500. I'm going to invest it. And I'm going to invest it for like 15 years so that my nephew, I can buy him a car when he turns 15. That's what you want to do with it. Okay, Maddie's very giving in that way. Good for you. So how do we figure out if we take $1,500 and invest it at a rate of 8% a year, and we compound it semi-annually, we want to find the value of the investment after 5, 10, and 15 years. I mean, you know, you get a little bit of money and you decide, I want to put that in a savings. It might be nice to know how much it's going to be worth after so much time, right? So how do we figure that out? We use this formula. The amount is equal to P. P is the principal. Principal is your initial investment times 1 plus R. R is the interest rate at which it's invested, divided by N. N is the number of times it's compounded over the course of the year. We raise that to the NT power, where N again is the number of times it's compounded and T is the number of years in which it's been invested. You good? So, what's that? R is the rate at which it's invested. So, the amount is equal to, what is P in this problem? 1,500 times 1 plus, what is the current rate? 0.08. So 8% we write as 0.08. Divided by, if it's compounded semi-annually, how often is it compounded? Twice a year. And I'm going to raise that to, I'm going to write it as 2t. Because we're changing the time. The time could be 5, 10, or 15. Agreed? So I'm going to just express this slightly differently. 1,500 times. What is 0.08 divided by 2? What's 8 divided by 2? 4. Good. So what's 0.08 divided by 2? So I get 1.04 raised to the 2t power. And instead of using my, just plugging in 5, 10, and 15 and doing the problem 3 times, what I'm going to do is I'm going to use the calculator to my advantage in this situation. And I'm going to go into my y equals, and I'm just going to type this in, and then I'll change the t value in the table. So using your graphic calculator can be super helpful in these times. 1,500, parentheses, 1.04. And I'm going to raise that to, and anytime you have more than one thing in the exponent, you need to make sure you put parentheses around that. So I've got 2t. There we go, and I close the parenthesis. Good? Now I go to my table. And I want to check it for 5, 10, and 15 years. I go 5, I go 10, and I go 15. And notice it computes those values for me very quickly. And if you actually highlight the value, it'll give it to multiple decimal places. So A of 5, if Maddie waits 5 years, her $1,500 turns into $2,220.37. If she waits 10 years, it turns into $3,286 and scroll down there, and 68 cents. And if she waits 15 years for her nephew to turn 15, she can buy him a car for $4,865.10. It's very nice of you, Maddie, to buy a car for your nephew. Just to be clear, are things going to cost more in 15 years or less in 15 years? So that 4,800 isn't truly 4,800, is it? It's actually a little bit less, which is unfortunate, but that's just the way it is. That's what is called inflation, right? That's why it's important to try to, you kind of want inflation to be low so that your money is worth more later on than what it would be. We currently have a super high inflation rate, but that's part of what you live with sometimes. Let's flip it over. So we're not going to do example 3. I'm going to show you something cool instead because people ask this question every year, and this is interesting to see why. But suppose that I change our little formula amount and I have this 1 plus, but what happens if we were to increase the number of times in which something is compounded? Say, the last one, how many times do we compound in a year? Like twice, right? And then, suppose instead of twice, suppose you did 4 times or 8 times, or suppose you did 100 times. What would happen to this expression as you compound it more and more and more, right? And you just figure it would get bigger and bigger, right? Well, think about this, and this is interesting to kind of consider. As x gets bigger, what happens to this thing? It gets smaller, right? Like 1 divided by a big number becomes a small number, right? Like, wouldn't you agree this kind of eventually goes towards 0? So you end up with 1 plus 0, which is 1. And then this thing became really big, right? What do you think 1 to the infinitieth power is? You would say it's probably 1, right? Because like 1 times 1 is 1, times 1 times 1, times 1 is 1, so on and so forth, right? But watch what happens. This is quite interesting. If I take my calculator, I type this in, we get something that you would not expect. And I'm going to go to my table, and so we're going to look at what happens if we do this. If we compound it twice, we get 2.25. We'll get bigger. We'll go 4. 2.4. It's getting bigger, right? I will go 8. Still getting bigger, but not that quickly, is it? Let's take a bigger number, like 20. Like still bigger, but not very quick, is it? Let's get serious about this. Let's get a big number. 100? Oh, wow. You guys are aggressive. It's still getting bigger, but not that big, right? Let's get a big number. Who said 3 million? Thank you, Luke. It's like my bank account right there. All right. Come on, folks. Isn't that the number E? Yeah. 2.718. That's the number E. As you compound something continuously, it ends up it doesn't just go towards infinity or explode. It actually turns out right to the number E. That's where E comes from. You want a bigger number? You want how about let's go. Let's just. Yeah, it actually steadily just hones in on 2 points. It just goes right towards E. Yeah, interesting. Yeah. All right, let's get back to money. A man invests $2,000 in an account that's compounded annually at an interest rate of 5.5%. What is the amount of investment after 4 years? You try saying that part up on your own. Ready, set, go. All right, let's see what we got. You got the amount is equal to the principal times 1 plus the rate divided by the number of times you compound it, raised to the nt power. Let's figure out what we got. The amount is, what's the principal? 2,000 times 1 plus, what's the rate? So 0.055, okay? 0.55 would be 55%. 0.055 is 5.5%. Move it 2 places. Divided by how many times is it compounded? Annually means once during the year, raised to the 4 times 1 power. So in other words, 2,000 times 1.055 raised to the 4th power. And you get, what'd you get?
2,477.25.
Okay, and so you'd have to decide, do you really want to invest that $2,000 if you're just going to make, say, $400 on it over the course of 4 years? I don't know what's happening in 4 years for you. You might be like, in 4 years, yeah, I definitely want to make sure I have that money around because at that time we're going to try to, put in a furnace. I want to make sure I've got good money there. Go ahead, it's up to you. Well, you might be like, that money right now is really important because we gotta do tires on the car or something. I don't know. Whatever, it's up to you. Let's do a problem that's much more interesting. I don't think that's as interesting. I like this question. How long will it take for the investment to double? Because I know that Gavin, he doesn't want just $2,400. He wants how much? He wants $4,000, right? So we're wondering, when is it going to reach 4,000? At that time, he'll pull it out and he'll invest it. He's going to go on a trip. He's going to go on a running trip. All right. So if it doubles, it's worth 4,000. So it says, how long does it take? So this time I'm solving for time. We've done this before, right? So I divide by 2,000, I get dos, which is Spanish for 2.
Right. 2 equals 1 plus 0.5.
Shoot, that looks confusing. Should we divide by 1.055? Should we subtract 1.055? Should we take the 1.055th root of both sides? What do you do? Very good. Log base 1.055 of 2 is equal to log 1.055 of 1.055 raised to the t power. Yeah, how do we even do that? Can you even do that? Is that a thing? Yeah. Yeah, Ella speaks forth. Words of wisdom for us. She says log of 2 divided by log of 1.055, and I get 12.95. We got t is equal to 12.95 years. So Gav's got to wait 13 years before it doubles. And so why is it taking so long? Well, it's only at 5.5%. But, if you want to have a guaranteed output, actually 5.5%, it's not that bad of an investment right now. Right now, if you put your money in a savings account, you get 0.1%, folks. 0.1%. Savings accounts are horrible. Does anybody know why your savings accounts are so low for interest? Because your housing rates are so low. Back when my parents bought their house, they bought their house a mortgage rate of about 13%. Super high. Right now, you get a mortgage for under 4%. So if the bank isn't getting much money on your mortgages, it's not going to give you much money back on your savings. So it all works in ebb and flow with each other. It is a great time to sell a house, not a good time to buy a house. Question? So I have 4,000 is equal to 2,000 times that. So if you divide both sides by 2,000, you get 2.
Oh, and then that 2 sticks around.
Log of 2, divide by log of that. Okay, they're all nervous coming. When they walk in, start clapping for them, okay? Yeah, of course, I know. Yeah, they really like you guys. Wow, look at that. Man, you guys are popular. Why don't you come have a seat right here, front and center? Yeah. Oh yeah. Woo! Okay, all right. Yeah, it's starting to go to their heads. They're starting to think, yeah, they're way too important now. We just got these two examples that'll help you, okay? All right, an investment of $800 was compounded quarterly over the course of 6 years. The initial investment reached $1,245.83. What was the interest rate of the investment? What am I trying to solve for in this problem? R. Say it again. Here's like your pirate. All right. So we're going to go amount is equal to we're going to Gavin control Michael. Okay? You don't All right. Okay, what's the amount?
800.
What's the principal? What's your initial investment? 800. 1 plus, what's the rate? R. Kelly, you didn't laugh. Yep, 4 times quarterly, so 4 times. Raised to what power, Wendy?
6 times 4.
6 times 4, which is
4 times 6.
24. Yep, 6 times 4, 4 times 6, either way is fine. Yeah, we divide by 800. Yeah, you're super good. Very humble, too. You're like the most humblest person I've ever met. We're going to divide that by 800. I get 1.557. Divide both sides by 24?
No, log.
Can I just move the 24 out in front?
Yeah.
No, there's no logarithm. Nope. Nope. No logarithm.
E. N. In.
No, log.
No. Only one of these 6 people may speak. I heard it. Yeah. Yeah. So here you go. So, folks, if it was squared, you would just take the square root of both sides, right?
Oh, yeah.
So it's the 24th power. So the way you get rid of a power is you do the 24th root. It is, but it's fun. Like, we've never done it before. It's like crossing new paths. Okay, so I got to take 1.557. I'm going to raise that to the 1 over 24 power. Yep. Oh, no. Don't do that, Mr. Gens.
It's 0.0648.
Yeah!
How do you know?
1.0186 is equal to 1 plus r over 4. Now what? Minus 1.
Oh,
And then I multiply by 4. Yeah, I subtract 1 and multiply by 4. R is equal to 7.45%.
And then you divide by 4.
Multiply by 4. All right, last problem. Ready? your last problem of the unit. Population of rabbits. Shh. Population of rabbits modeled by that thing. P is in thousands. So suppose you come out with, say, 3 for P. What does that mean? Population is 3,000. Is the number of rabbits. T is the number of years that the population is tracked. Shh. Find the population after 10 years and find how many years it takes for the population to reach 8,000. I'm wondering this. What does the population start at? I'm wondering population at time 0. And that's not part of the problem, but I'm just curious. I want to figure that out so I can get a sense of what's happening with the whole problem. So in order to find P of 0, I would plug in 0 for what? T, right? So the time is 0, so I got 30 divided by 1 plus 5e, and what is negative 0.3 times 0? 0. So we'll figure that out, and that'll give us like the population at time 0. So what's e to the 0? 5 times 1? 6. 5 times 1 is 5, plus 1 is 6. 3 divided by 6 is? So that means the population is 5,000. That's what we're starting out with, okay? So we want to find out the population after 10 years. So what would you do? Plug in 10. So I've got 30 over 1 plus 5e to the, and what's negative 0.3 times 10?
Negative 0.3. Negative 3.
Negative 3. Thank you, Olivia. We're bound to get it right. All right, so I'm going to take that divided by that. I got to make sure that I plug this into my calculator correctly using parentheses. 30 divided by parentheses. I've got 1 plus 5. And I've got e raised to the negative 3 power. So I plugged in 10 for t. What is negative 0.3 times 10? It's negative 3. I press enter, and I got 24 rabbits. 24,000. So I got 24,020 rabbits. Wow. Those rabbits, they reproduced. That's kind of what they do.
Wait, how did you get 24? I have 29.
Yes. Yes, you did something wrong. Yep, I'll show you later. Okay, last question. Find the population to 10. We did that, but find how many years it takes for the population to reach 8,000. So what am I solving for? Solving for the years. What do I plug in for P?
No, nothing. 0. Wait.
I don't plug in 8,000. I plug in 8. Remember, it's measured in thousands. So 8 equals 30 over 1 plus 5e to the negative 0.3t. So the question is, when does it reach 8,000? P is represented in thousands. So instead of writing 8,000, write 8. Okay. Now, hopefully you recognize this from a different problem we did earlier. How do you want to solve this? Let's go. 30 equals, I'm going to raise 8 times the quantity, 1 plus 5e to the negative 0.3t. If you wanted to distribute that, you could, but I'm just going to raise 8 times. Now what? Divide by 8. 30 divided by 8. Very good. 3.75. Well, 24 divided by 8 is 3 with a remainder of 6. So 6/8. So 3 and 6/8 is 3 3/4. Now you subtract 1. We get 2.75 is equal to 5e to the negative 0.3t. Divide by 5. I got a little trick for that. This thing divided by 5 is 0.55. And Caitlin, now what do I do to both sides? Natural log. Lump it. And when I do that, I get negative 0.3t, and the natural log of 0.55 is about negative 0.6. 597? Yeah. I did the problem earlier, you guys. All right, I divide both sides by negative 0.3. I'm really not as smart as what I sound like, trust me. You're right, I did that by myself. Okay, maybe I'm really smart. Okay, I told you. T is equal to 2 years. Oh, all the problems in your assignment follow examples like we did in class. Doesn't mean that they're easy, but does mean that you can do them. I'd be happy to help you. You guys have a wonderful day tomorrow. Remember,